I am Rao Singh Rawat from the Department of Mechanical Engineering, IIMT College of Engineering, Greater Noida. In the last lecture, we have seen about the air conditioning and psychromatic properties. Taking a small review on air conditioning and psychromatic properties, if we talk about the air conditioning is the process of simultaneous control of air temperature, air humidity, purity of air and air velocity. If we talk about the refrigeration, it is the process of maintaining the lower temperature compared to surrounding temperatures. Okay, so in the last lecture we have also studied about the specific humidity and relative humidity. Today we will see the derivation of specific humidity and relative humidity. Derivation of specific humidity. If we talk about the specific humidity, it is the ratio of mass of water vapor present in atmospheric air to the mass of dry air. So its unit becomes kg per kg of dry air. Kg of dry air tells about the dry air parts. Okay. Now we will see the derivation of specific humidity. We have to prove that omega equal to 0.662 PV upon P minus PV, where PV is partial pressure of water vapor and P is the total pressure of atmospheric air. Okay. If we talk about the atmospheric air, it will consist about the two pressures, because it will consist about two parts. First one is dry air parts and second one is the water vapor part. Water vapor part is depend upon the climate and dry air part is fixed, which consists about the nitrogen, oxygen, carbon dioxide, sulfur and CO. Okay, we have last lecture we have seen it. Okay, if we talk about the partial pressure of water vapor, it is the pressure exerted by the water vapor present in atmospheric air, that is the pressure. Okay, we will prove. Consider a mass of atmospheric air that consists about the mass of dry air plus mass of water vapor. V is telling about the vapor part, water vapor part. Okay, if we talk about this volume, this is the by volume is V and by the temperature is T, and the pressure of this is PT, total barometric or atmospheric temperature pressure exerted by this volume of atmospheric air. Okay, if we talk about this part, MA, same volume, MA plus MV. The pressure of dry air part is PA and pressure of water vapor part is VP. Similarly, specific volume is VA and this is VV. And the temperature is T and volume is V. If we talk about dry air and water vapor part, dry air and water vapor part separately known as ideal gas, but the mixture of atmospheric air is not ideal gas. Okay, but the water vapor and dry air is ideal gas, so it is going to follow the PV equal to MRT, which is perfect gas equation. Okay, if we talk about the perfect gas equation, that becomes PV equal to MRT, where P is the pressure, V is the volume, M is mass, R is characteristic gas constant, T is temperature. If I am going to apply this perfect gas equation for dry air and water vapor, so for dry air it becomes PA VA equal to MA RA TA. Okay, if we talk about the whole bundle of atmospheric air, it consists about MA or MV. So if we talk about the volume, it by volume is V. Okay, volume of air and volume of vapor is same, that is the capital V. Okay, and similarly temperature is also same. So this equation becomes PA into V equal to MA RA into T. So this is equation number, suppose that A. Similarly, for water vapor, it becomes PV, VV, MV, RV and TV. If we talk about the conversion of this equation, VV is similarly volume V, MV remains MV, RV remains RV, T temperature is T, because the temperature of atmospheric air is 1, only T, and similarly we are considering some volume V. So V is also same for dry air part and water vapor part. So this equation becomes like that, and this is equation B. We have to find out the value of specific humidity. Okay, so if we are going to dividing equation B by equation A, so it becomes PV V into upon PA V equal to MV RV T upon MA RA T. We know that MV upon MA is omega. V cancel out, T cancel out. Okay, so we can write PV upon PA equal to MV upon MA into RV upon RA, and this term is known as omega, specific humidity. So can I write this omega equal to PV upon PA into RA upon RV. So this is the equation of omega. Now we have to do it, we have to convert this equation into R. So this is RA is characteristic gas constant of dry air part and RV is characteristic gas constant of water vapor part. If we will see from here, we know that perfect gas equation is PV equal to MRT. Okay, PV can be written, PV equal to M can be written as N number of moles into molecular weight into R into T, and this equation can be written as N R bar T, because R bar is equal to M into R, where capital M is molecular weight and R is characteristic gas constant. So I can written from here RA equal to R bar upon MA. Similarly for RB, it can be written as R bar upon MV. Okay, characteristic gas constant of RA is, characteristic gas constant is depend upon the universal gas constant R bar and molecular weight of RA. So MA becomes, this is 28.966 gram per mole. This is the molecular weight. Similarly MV becomes 18.02 gram per mole. This is MB is water vapor as 2O. So 18 is this like that, 18.20. If I am going to putting these values in equation number this first, so this becomes omega equal to PV upon PA into RA. RA is R bar upon MA. MA की value, the value of MA is 28.96 upon R bar upon MV. MV is 18.02. R bar cancel out. So this becomes omega equal to 18.02 upon 28.966 PV upon PA. Okay, and if I am going to divide this becomes 0.622 PV upon PA. Okay, PV upon PA. So your omega becomes omega equal to 0.622 PV upon PA. We know that from the law of partial pressure of Dalton, total pressure equal to the pressure of dry air plus pressure of water vapor. So total pressure is P, and this is a PA plus PV, and PA becomes P minus PV. Okay. So from this we are going to putting the value of PA. So this becomes omega 0.662 PV upon P minus PV. If we are going to analyze this equation, this tells about the total barometric pressure of atmospheric air and partial pressure of water vapor. If we talk about this denominator part, this is the total barometric pressure and partial pressure of water vapor, and PV is very less than the total pressure of atmospheric air. Okay, so we can say that P minus PV is approximately equal to total pressure of atmospheric air. Okay, so this equation becomes 0.662 PV upon PT. PT is atmospheric pressure. So this equation is the function, omega is the function of PV only, that is PV is partial pressure of water vapor. So we can say that specific humidity approximately linearly to the partial pressure of water vapor present in atmospheric air. So this is the derivation for specific humidity. Okay. Now we will see about the capacities of air conditioning. Capacity of air conditioning. If we talk about the capacity, it is the amount of heat removed from the air. It is the amount of heat removed from the air. So this is capacity is RC equal to in TR, ton of refrigeration. Okay, ton of refrigeration. So TR is equal to 1 TR is equal to 3.51 kilowatt. We will see this proof. TR 1 TR is nothing. It is the amount of heat removed from 1 ton of water at 0 degree Celsius to convert it into ice in 24 hours at 0 degree Celsius. Okay. So this is the 1 TR is nothing. This is the amount of water, 1 ton, 0 degree Celsius. The heat is going to removed, QR removed, that is going to convert 0 degree Celsius into ice in 24 hours. In 24 hours. Okay. So this is process is known as 1 TR. Okay. This process is known as 1 TR. How 1 TR is equal to 3.5 kilowatt? We will see the proof this. Okay. If we talk about this conversion, this is the phase change process, because we are going to convert the liquid water into the solid state. So this is known as latent heat of solidification. So during this conversion there is a latent heat of solidification. And latent heat of solidification for the water is HFG is 335 kilojoule per kg. Okay. If we talk about the 1 ton, this is by US. So US 1 ton is equal to 907.185 kilogram. Not for Indian 1000 kg. Okay. So if we are going to find out this rate, so rate of heat removed is equal to mass of water into HFG of water of solidification upon time. Time is 24 hours. Okay. If we will see, this becomes mass of water is 907.185 kilogram into HFG, latent heat of solidification 335 kilojoule per kg, and time is 24 hours. I am going to convert this into second. 24 into 60 into 60. If we are going to find out this value, this becomes your 3.517 kilowatt. So this is 1 TR, and this is also you are going to convert in 210 kilojoule per minute. You are also going to convert in minute. Thank you very much.